Hey, welcome ladies and gentlemen. Today you're at another edition of Sin Hardware's Tekken 10. Today we're going to take a look at a Z77X-UP5-TH. It is Gigabyte's, one of Gigabyte's brand new ultra durable 5 motherboards. I think you guys all know they just went through ultra durable 4. Here's the deal. Ultra durable 4 was basically prominently displaying the features that some of which were already present. The new fiberglass PCB is newer and basically one of the biggest parts of Ultra Durable 4. However, many of the features of Ultra Durable 4 Gigabyte already had in there. However, other manufacturers didn't do it and Gigabyte wanted to show. Ultra Durable 5 is a totally different thing. Ultra Durable 5 still includes everything from Ultra Durable 3, 2, 1, and 4. However, it also features high current capability parts. The most prominent of which is the IR3550. Won Product of the Year award from CES, Best of Computex from Tom's Hardware. It's rated 60 amps. That's higher than any power stage I've ever seen. I've seen MOSFETs rated much higher, however, I've never seen thermals rated so well. That means that IR made a challenge to other MOSFET makers. They're like, can you show us something that can beat ours? Let's have a contest. At CES, IR demonstrated that their power stages are the best. They went to their top competitor and were like, here, bring out your game, your A game, and they beat them at their A game, and that's why IR won the Product of the Year award. That's why they can say industry leading, 60 amp rated, is legitimately 60 amps, can be done with a normal heatsink on it. On the back of the board, tons of good features here, right? Dual Thunderbolt, dual UEFI BIOS, tons of marketing right here for the power stages, all the included utilities, and like the UEFI. You have dual band Wi-Fi right here. You have Sound Blaster XFI with 110 decibel playback. 110 decibel playback usually designates Realtek ALC 898 codec, which is what is included here. However, Gigabyte has not talked about the amps they've used for headphone front and rear, and that is also included on this board, just like the UD5H. Alright, so let me do a little unboxing. First we have the board. This is not in static packaging, which it usually is, but the deal is that I've done many shots of this, so I'm going to put the board aside for a second, and I'm going to take a look at the accessory packages. Alright, here's our Wi-Fi module. It is much smaller than the other one, mainly because you only have to plug in this little tiny USB cable to this little header here and then to the board. There's no external USB header port like there are on the other ones. Plus, this is WB300D, the top model at the moment. I'm pretty sure you can try to buy it separately, and comes with 2 high-tech antennas and this cable. Tons of manuals and goodies here. A single SLI, back panel I/O, 6 SATA 60 gigabytes per second cables, bunch load of those. And here we have a front panel USB 3.0 header. Most cases won't fit this natively, however, all of them, or you can go buy one for a few bucks that'll allow this to be adapted to one of your case's bays. So now let's take a look at the board, right? Shall we? UP5-TH. Please ground yourself before touching such a beauty. This is one hell of a motherboard, one of my favorites at the moment. So let's take a wonderful look at this baby, alright? So I would really like to say that I think Gigabyte did a wonderful job with this board. I've been testing it for a little while now, and I can say with confidence that Gigabyte is aiming to make this one of their best boards. And they have the capability to do it, and pretty much if you try one out, you'll see what I mean. Here you have a fan header, another one right here, another one right here, one down here, and the 5th one down here. There's some kind of fan control in the BIOS that could be improved on, really, and that is one thing I do have a gripe with, is that they should improve their fan control. Anyways, so we have tons of overclocking features: power button, reset, clear CMOS, voltage read points. These are a big one, boys and girls. Not many motherboard manufacturers give you this on a board. Even though it's one of the cheapest things to integrate, it is one of the best things to have. postcode LED, one of the other best things to have. You can always make your own power, reset, and clear CMOS buttons. You can't make your own postcode display. You can make your own voltage read points, but you're going to avoid your warranty. And you have a dual BIOS switch. Dual BIOS is not something you can just go get. You have one here and one here. That's redundancy. This is something else that's extremely special and you cannot add on. Only the manufacturer can. And that's ATX4P, which is basically extra PCIe power for these, because you can run 3-way crossfire. Now let me tell you how you can do that. 16X from the CPU is transferred to this first 16X slot. Then you have an 8X slot here, then a 4X slot here. These 4 switches, each of these 6 switches basically, can transfer 2 PCIe lanes, correct? 3.0 switches, anyways. So these 4 in the top, they transfer this second 8X, the second 8X of the first 16X slot to the first 8X of the second slot. These 2 switches are hooked to the second 4X of this 8X slot and can transfer them down to the 4X here. So basically, if you put a GPU in here and here, it'll take 8 lanes from here and put them here, right? So 8X, 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 8X. Now if you put a third GPU here, it'll take 4X from here and move it down here. So now you have 8X, 4X, 4X, 8X, 4X, 4X. You got that? Cool. Alright, then you have a Thunderbolt controller here. That's another big feature people have been wondering about. This is dual 10 gigabytes per second. Basically that means that each of these ports can supply 10 gigabits per second, gigabytes per second. It uses up a lot of PCIe lanes, and I'll describe to you how they do that later. Here we have 7.1 surround sound. It's in a Toslink connector. That's funny. Anyways, you also have SPDIF out, dual Thunderbolt. You have 4 USB 3.0 ports in the back, 2 USB 2.0 ports, an eSATA 6 gigabytes per second port, and a gigabit Ethernet port. Then you have HDMI right here, DVI right here, D-sub right here, which is also known as D-sub. So going back to the board, we'll talk about the voltage regulators in a little bit. Here we have the PCH, and it only has 8 PCIe lanes, right? However, the USB 3.0 is also here. You have 6 ports here. I'm going to talk about the rest later. The PCI connectivity later. Let's talk a little bit about 3.0. You have 3 3.0 headers. That means 6 total ports. This natively connects to the PCH through 2 of the 4 native ports from the PCH to this header. Then the VLI hub here takes 1 port and makes it 4, and another VLI hub here takes 1 port from here and makes it 4. Now the benefit of the VLI hub here is that the VLI hub can also take the signal and strengthen the signal, as USB has huge distance issuings, right? So if you take a port from here and put it here, that might work, right? However, if you want to put ports over here, just a small change in distance from routing from the PCH to the front for the back panel will cause signaling issues. Thus, the VLI hub is actually doing something more than just multiplexing the ports. It's also helping the signal integrity. Thunderbolt has tons of onboard components, has its own voltage regulator module here. And now let's move on to the whole digital signaling process of this motherboard, right? Now this motherboard uses 3 digital PWMs to give out your voltage rails, right? Here's the deal. Every modern voltage regulator on a motherboard needs, on a Z77 motherboard, and if it wants to support video outputs, it needs at least 3 separate voltage rails for this VRM right here. It also needs 1 other separate voltage rail for this, and it might need another one for this. Well, it of course needs another one for this, which is for the PCH, right? So that means in total you need at least 5 outputs, okay? And most PWMs are dual output PWMs. However, this PWM here is not a dual output PWM. It is an IR3563 digital pulse width modulator, 8 plus 0 phases. That means 1, 2, 3, 4, 5, 6, 7, 8 are directly routed to this. True 8-phase PWM means less ripple, better performance, and just overall lower temperatures. Each one of these phases is on 1/8 of a cycle, so not for the total cycle, and that gives for better thermals and better performance. So basically, the more true phases you have, the better. However, most PWMs are not 8 plus whatever. They're always 6 plus something or 7 plus something. and that's for the most part, or 4 plus something. That means many 8-phase PWMs, like you see on boards like the Ace Rock Extreme 4, are actually 4 phases doubled, and that's just crap, right? You don't want that. So right here, this 8 true phases for one of the best voltage regulators. This is like ROG style, okay? ROG is the only other brand that I know usually uses 8, except in the lower end. Like if you're paid less than like $250 for a ROG board, you're probably not going to get 8 true phases. However, then we have a dual output PWM here. This is an IR3570, and this is 3 plus 2 phase. Not all the outputs are used. 2 phases go here, and 2 phases go for iGPU. This other one is the same exact type PWM, just a second one. 1 phase for the PCH, and a second output goes for the VTT. So you have that. So let's take the heat sinks off, because they're pretty cool to see this time. Now you see there's not many screws here because I've taken them off. Basically, Gigabyte has added retention brackets to the back, and I think they just did this for styling. However, it also has one other benefit. It keeps the board extremely, extremely stable. That means that when you hold this board, you cannot flex it. You can put an extremely heavy heatsink on this board, and this strong metal aluminum clip will keep the board strong. And it has a padding between the board and itself so that none of the little MLC capacitors get smushed. And it gives excellent protection if they're backside MOSFETs, but of course we're using IR power stages, so there's no backside MOSFETs. I did that so I can remove the heatsink. Then we have this beautiful board right here. Give you a nice up close look at this. Look how gorgeous these power stages are, right? Look how gorgeous this heatsink is. This is a wonderful looking heatsink. The thermals are going to be great on this, not because of its one piece. It's not like the other one. However, it makes up for the one piece in mass as well as airflow dynamics. Look how much airflow you can get in there. Look how much airflow you can get in there and kind of trap through this top part. And it might actually improve thermals. Thermal contact is good. You can actually see an impression of the MOSFETs here, even though you can probably run it without a heatsink. Anyways, so we have the VRM here. These are IR power stages. You can tell they're rectangles. They're lower wattage, lower current type of these power stages used on Gigabyte X79 boards for the DRAM power. Anyways, other manufacturers might use these same power stages and rename them. Basically write like ASP on it. You can tell by their length and width how much power they output. These are the max because Gigabyte doesn't rename them. Basically, you can go in Photoshop, find out the length of the board from the manufacturer's stats, and then find out the length of each one of these. And you can go online, and if it's renamed, you can find out exactly how much it is. Because I do believe other manufacturers will adopt this, because currently this is the ultimate solution. For the first time, Gigabyte has leading power delivery design in the same phase quantity, and they're kicking ass. You cannot make an 8-phase power design without these chokes and these MOSFETs and claim 60 amps per phase. Anyways, so I'm going to show you something I drew up. Let's do this real quick. This is going to explain a lot of stuff to you, okay? A lot of stuff I'm talking about. So first of all, how the hell can Gigabyte pull so much connectivity out of a motherboard if the Thunderbolt controller uses 4x PCIe lanes, right? And that's a lot, right? The issue is that the PCH of Z77 only has 8x PCIe 2.0 lanes. Now this is not the CPU's GPU PCIe controller, which is 16x 3.0. No, this is 8x 2.0, and that's for all the connectivity. The extra Marvel port here, the extra eSATA comes from a Marvel connector here. Then you have all these 1x slots, right? And they all need 1x connectivity. Then you have this PCI slot. PCI is not native to Z77 chipset, so it needs a converter. Then you have VIA 1394A, which is right here, and that needs its own converter. Basically, Gigabyte does some pretty fancy stuff. They take one lane. Well, first of all, they route 4 lanes to Thunderbolt controller right there. So that's provided to Thunderbolt. 4 lanes are gone. You're left with 4. So 8 minus 4 equals 4. Then you take one lane and you give it to a ITE 8892E. Now this provides 2 PCI outputs, one for 1394A and one for PCIe, to here and here. So basically you don't need extra 1x lanes for here. So that's basically minus 1. So now you're left with 3, right? Now you're left with 3. 1 goes to Marvel for SATA and eSATA, so minus 1 again, and you're left with 2. The Intel NIC always needs its own lane. So that's -1 again. You're left with only one more left. So what does Gigabyte do? They need to power some of these 1x slots. Remember, we haven't covered them. Imagine how much of a bitch that is. To have so much connectivity that needs its own lanes, and Intel only providing 8x lanes with their own Thunderbolt controller that eats up 4 lanes. They basically only want you to use Thunderbolt on a motherboard, which is just BS in my opinion. So Gigabyte and other manufacturers have to take a step up. Gigabyte's the first one I've seen to use a PX8605. Well, not one of the first, but one of the few. And this is a 3-to-1, so it'll take one lane and turn it into 3. And basically it'll turn into 3 here, so each one of these gets its own lane. Usually these slots, 1x slots, use switches like this, or 2.0 switches like this, and they'll switch and they'll train. So you can only use one at a time, or they'll alternate with the last 4x. However, this 4x is connected to the CPU, so that's not an issue. Anyways, that's how that works. So that's how you get all your connectivity. I also want to mention you have an ALC898 codec here. This is an audio amplifier, and this is an audio amplifier. This one goes to the back, this one goes to the front. These audio capacitors and a couple of these capacitors are used to smoothen out the link for the toss link. Anyways, let's talk about this. Vrm Current Limits. There are 3 current limits that are huge. PCB traces, the MOSFETs, and the chokes. Now, power stage is made up of a driver and the MOSFETs. A high side MOSFET connects a 12-volt input from here to the load, to the CPU. However, before it goes to the CPU, it has to go through the choke. The low side MOSFET, which is the other MOSFET, connects the load to the ground when the phase is off. Remember, they're only on 1/8 of the cycle. So a low side MOSFET completes the circuit. However, the high side MOSFET will limit your current, alright? And the inductor is standing between the power stage and the load. So the inductor will limit the current. That is why Gigabyte uses 60 amp chokes, while Gigabyte uses 60 amp power stages to match the chokes. Other manufacturers do not do this, alright? Never, almost never is a choke rated higher than the MOSFET, because usually MOSFETs can never do what they're rated. However, this time they can do what they're rated. Gigabyte felt like doing it. There's one more thing I want to cover because we are running out of time. We're about 7 minutes over. IR3550 uses direct FET technology. Now, I talked to Deepak Saviti at Gigabyte's Computex suite, and he went over a few things with me that Gigabyte does not mention in their marketing material, but I feel actually they kind of do, but not as big as they should. Direct FETs, you all know from Asus's ROG series of boards and older Volterra type designs. Basically, direct FETs are a lot of copper, a nice metal package, so they have excellent thermals all around. However, IR makes direct FETs. However, they also implemented direct FET technology into their power stage so they could have the highest output per power stage. They implemented something that I think is really cool. First of all, PWM connections can move from this PWM all the way over here. There's no distancing issue. It can move halfway around the PCB. However, the driver signal, this is PWM to driver's PWM signal. Between driver to the MOSFETs, the driver connects the gate of each MOSFET individually. That signal has to be extremely close to have better signaling qualities. So on the direct FET, they use gold connections inside on a micro scale. They use gold connections here between the gates of the FETs and the driver, as well as the guide driver to the pins on the outside. Imagine that. You have gold in every single one of these is real gold, the same as in the other direct FET. They also use a full body copper clip outlined in red right here. That connects the high side FET and the low side FET with a big copper clip on top, and that helps distribute the current very evenly, so it goes in the PCB, which once again, the PCB is the limit, remember? However, Gigabyte is using 2-ounce PCB. If they're not saying 2-ounce copper PCB, most of the time they're not using it. Also, IR says that they're using extremely high quality copper with no impurities, well, very little impurities basically. Also, IR PWM and IR power stage are being used at the same time. Now that means if there's some certain digital signals that need to be sent from PWM to driver to correspondingly switch the high side and low side FET correctly, or the PWM's duty cycle and switching frequency correctly match the high side and low side FET's characteristics, then it can correctly introduce it through the driver. IR has basically their own special protocols going here, which can of course use other vendors for other parts. Of course, like these MOSFETs are not from IR, they're actually from Renaissance, and they're using IR PWM to drive them. However, this is more optimal to use the IR power stages, and so Gigabyte has given you the best design. In my opinion, this is the best voltage regulator you can get on any motherboard to date. That's my opinion, of course. I like true phases. This is the first time Gigabyte's ever used 8 true phases. Other designs like 24 phase designs, they're awesome. However, there are only 6 true phases. However, here we have 8 true phases. Less is better in this case. I'm actually excited for the UP7 because in that case, you basically have 4 8-phase voltage regulators, and only one of them is on at a time. That's another deal and another day, and that uses different switching technology than Gigabyte has used in the past for their 24-phase boards. So I'm going to go over those later. If you want, you can save this picture and see what's up. Sorry, this is Sin Hardware Tekken 10, which is actually double the time now. Alright guys, I hope you have a good evening. Take a look at the UP5-TH review I'll have up very soon, and have a great day. Thank you.